Hello everyone. So let's try to go for one more problem from IE Irodov, and this is again from the kinematics question. This is wonderful question, very conceptual in nature. And let's see what is this particular question. Then we will discuss in detail. And this is very conceptual question. What is this? This is question number 1.5. It is given that two particles 1 and 2 move with constant velocity v1 and v2. At the initial moment, their radius vector are r1 and r2. How much of these four vectors will be interrelated for the particle to be collided? So it's a wonderful question. So what is this? Initially, the particle 1 is at the r1 position vector. Initially, particle r2 is particle 2 is the r2 vector, and its velocity is given v1 and v2. It is given, and after some time they are going to collide. So what should be the relationship between these position vectors? So this is wonderful. Let's try to solve this one in a very nice way. So if you have to go for the vector diagram actually, then we can easily solve this one. And this type of problem you can solve with the full of basically concept. There is not more calculation. So let us write the whole story of this. So suppose this is something x and y. Initially, my particle is at position vector r1. So this is r1. This is for the particle 1. And again, the particle 2 is the position vector r2. And at this particular point, they have velocity v1 and v2. So v1 and v2 is also a vector. So what will happen? After some time, let us assume they are going to collide at this particular point. So what will happen? So this position vector is v1 t, and this position vector is basically v2 t. And we know that velocity at this point is v1 and velocity at this point is v2. And we can assume these all are given in terms of vector one. And what will happen? This is the resultant vector. So if, and let's say this resultant vector is r. So what will happen if these two particles going to collide at this particular point? This is particle 2. That means this resultant will be common to r1 and v1p, and which is also common to r2 and v2. So how we will write this? So when we will write this, then what we have? We have basically r1 plus v1 t must be equal to r2 plus v2 t. And from there, we can easily find the value of t. And from there, we can easily write that value is equal to r1 minus r2 must be equal to v2 minus v1 into t. And from there, we can calculate the value of t. And t is the scalar quantity, it is always positive. So what will be your t? Your t will be r1 minus r2 by v2 minus v1. And we have to take the modulus of this because time is always a scalar number which is positive. And now we can put the value of time here. We can put the value of time here. Then what we will get? We will get basically r1 minus r2 is equal to v2 minus v1 into time. And that time is in the magnitude part. And that value is equal to r1 minus r2 we have by v2 minus v1. This is the part. So now we can separate the position part together and velocity part together. So what we have? We have basically r1 minus r2 by mod r1 minus r2 must be equal to v2 minus v1 upon we have v2 minus v1. Let me check. This is r1 minus r2, v2 minus v1. This is the time. So this is your particular value. So this is actually relationship between position and velocity. You can easily find. So this is a wonderful question. You can solve with yourself and and this is and beautiful thing is that how you can visualize the time of collision that is in form of vector. So this is very interesting. So just try to do with yourself this particular question, and if you have any doubt or any correction, let me know. Thank you.